Hey guys, happy Wednesday. Okay, yesterday we talked about outliers. Today we're going to do a little bit more with outliers, kind of explaining. Remember, outliers are liars. So we're going to see what I mean by that and how they actually make data lie or tell a story that's not actually there. Go ahead and do your PDN. Come back when you are ready to check it. Okay. Hopefully you came up with a definition for outlier. Which number in this one is an outlier? The 92 is an outlier. Everything else is in the 30s or 40s. 92 is super far away. Reasons for that outlier? We'll see what you had to say. Remember that these were math scores. So I'm going to check what you put for that. Okay. Jay-Z says numbers don't lie. Today, we prove him wrong. Yesterday, we identified what outliers were. Remember, outliers are numbers that are way bigger or way smaller than any other numbers. Today, we're going to look at how those outliers can affect the measure of center or the mean. The example I gave yesterday was how one low test score of like a 20 when everything else was in the 90s is totally going to bomb your grade. That's what an outlier does. It totally changes the average to make it way bigger or way smaller. So we're going to look at the same data that we looked at yesterday. Here are the Warriors' wins for the last 8 years. We said yesterday that the outlier was 15. Okay, now we're going to be putting together that along with a lot of information that we did last week, excuse me. The first thing we need to do is we need to find the mean of all this data. So on my scrap paper, I'm going to write out 57 plus 58 plus 47 plus 67, 15, 67, 73, 51. To find the mean, I got to add those all together. I'm sure none of you are using a calculator. No way. Okay, when you add all of those together, not using a calculator, I'm sure you came up with a sum of 435. When we get 435, remember that's not our mean. We still have to divide. We're going to divide by 1, 2, 3, 4, 5, 6, 7, 8. 435 divided by 8. You can stop at the tenths place when you do this on your scrap paper. 435 divided by 8 is 54.3. If you go past the tenths place, I know you used a calculator, and I'm probably not going to say anything because that's okay to use a calculator on this. So our mean is 54.3. That's all the data together. We added it all up. We divided by 8 because there were, and we get a mean of 54.3. We now have to calculate what the mean is without the outlier. Now, I'm crossing out this outlier. Maybe a fifth grader would go through and re-add these numbers, but let's think of a quicker way that we could do this. Rather than getting our scrap paper, getting out our scrap paper and adding these numbers all up again, I think there's an easier way to do it. Instead, I know that originally all the numbers together were 435. I also know that I no longer have a 15. So I'm just going to take that 15 out. And what do I get with all the numbers? Then I get 420. So I don't actually have to add these all up again. All I did was took my original total, 435. That's when I added them all up the first time. And I subtracted 15 from it because I was doing the same thing, except this time I wasn't including 15. Okay, I'm not even close to done yet. I have my new sum, which is 420. I still have to find the mean, which means I still have to divide it by something. Now, on this one, for the whole set of data, I divided by 8. But I don't have 8 numbers anymore. I have 1, 2, 3, 4, 5, 6, 7 numbers. So this time I'm going to divide by 7. And luckily, this is a problem we can do to our head. 420 divided by 7 is 60. Okay, so with all of the data, they averaged, or their mean was 54.3 wins. Without that outlier, without this year, before this year, they were averaging 60 wins. Okay, so the outlier makes the mean lower. The outlier of 15 made the mean 54, whereas without the outlier, the mean was 60. Here's how we can think about it. If the outlier is way bigger, the mean is going to be higher. It's going to raise. If the outlier is way smaller, like 15 here is way smaller, it makes the mean lower. So we're going to say that the outlier lowered the mean by almost 6 wins per season, because we went from 60 all the way down to 54 because of that outlier of 15. Take a breath. That was a lot. Because it was a lot, you're only doing 3 problems today. You're doing 1 for problem set 1, smaller numbers should be easier. You're doing 1 for problem set 2, smaller numbers should be easier. And then you're doing an exit ticket. So it's only 3 problems today. So don't worry, it's still only gonna take you about 10 more minutes to finish up this lesson. Go ahead and do number 1 right now. Come back when you are ready to check your answers. Okay. Your first step was to add up all those numbers. When you add them all up, you should have gotten 39. That's not the mean. We have to take that 39 and divide by 2, 4, 6, 8, 10, 12, 13. Because there's 13 different numbers. So it's 39 divided by 13, which gives me a mean of 3. Now, my outlier here is 15. So to find my new sum, when I add them all together, I got 39. This time I don't want to include 15. So I'm just going to subtract, and my new sum is now 24. So my new sum of 24, before I divided by 13, but this time I'm not doing 13 numbers because I'm not counting this one. So this time I'm only doing 12 numbers. 24 divided by 12 gives me 2. How does the outlier affect the mean? Remember, the outlier was way bigger, so that means it raised the mean. The outlier raised the mean. And what did it raise it from? Well, it was 2 without the outlier. With the outlier, it's 3. So raise the mean by 1 whole foul shot. Okay, because we went from 2 to 3, it raised it because the outlier was bigger. If the outlier is bigger, it raises the mean. If the outlier is smaller, it lowers the mean. Okay, go ahead and get started on number 2 now. Pause the video, come back when you're ready to check the answers. Okay, first thing we're gonna do. This is 1, 2, 3, 4, 2, 4, 6, because this is 2, this is 2, this is 2. So 6 plus 1, 2, 3, 4 gives me 10, plus a 3, 13, plus another 3, 16, plus 4, 20, plus a 7 gives me 27. How many numbers are there up here? I'm just going to count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to do 27 divided by 11. I can always stop at the 10th spot when I do that division problem, and I get 2.4. My sum before was 27. Without the outlier, I want to take the outlier out. So the outlier was 7, and I want to take that out. So I'm going to do 27, and I'm going to take out the 7. So my new sum is 20. Now I'm 20. I'm not going to divide by 11 again because I'm no longer using this number. So now I'm just looking at these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to divide by 10, which gives me a new mean of 2. How did the outlier affect the mean? The outlier was way bigger. So the outlier, if it's bigger, it raised the mean. And let's see what it raised it. It's 2 compared to 2.4. So it raised the mean by 0.4. What are we talking about here? We're talking about paintings, 0.4 paintings. Remember, the last step is always to describe how that outlier is doing it. Okay, you have one more question left, your exit ticket. I'll give you feedback on that once you have submitted it. As always, you have a challenge question on Khan today. Still only 4 problems, but it's really going to get you thinking. And then actually that's the last Khan assignment we're going to do this week. After that, Thursday and Friday of this week, I'm just going to have you go back and check on ones that you haven't finished yet. As always, call or text with any questions, 847-769-4731. Thanks, and I'll see you guys back here tomorrow.